it up and running here. It's been a little bit tricky, but today we are going to get into some combination questions. So combination questions are one of those topics on the GMAT where I think initially a lot of us are generally scared by them, but they're really not that bad. As I like to say, the scope of them is usually pretty reasonable. I don't think they get all that nuts. So what I want to do here is I want to get into, we probably won't do permutations today. We'll stick with more combinations. We'll do some at least questions. Let me just get this open and we'll get going. But yeah, try not to be super intimidated by this problem type. I do think going into the GMAT, a lot of times people are, just because for whatever reason, they haven't seen it in a while. I mean, there's a million different reasons, but yeah, you just gotta try your best to understand that it's not that bad, and that if you know the basics or things like where people struggle, like, hey, am I dealing with a combination or am I dealing with a permutation? Like people, you know, all the time ask about that. And I don't think, to be honest, that that's that bad of a thing to recognize, you know, when order matters, when it doesn't. Like if you're picking a team and there's no specific positions to that team, it's just going to be a combination. If you're picking a team, but now all of a sudden you have positions, like say a baseball team, first base, second base, third base, well then order matters because whoever's at which base changes. So, you know, these are just things to kind of keep in mind. And like, I do feel like these are some of the concerns that people have going into these questions. But, you know, for instance, at the beginning of our chapter, we go into recognizing a combination versus a permutation. And that's something, you know, you want to learn early on. So anyway, let's jump into one of my favorite questions just because of how it is stated. Let's start with this here. All right, take a look at this question. I'll give you guys a few minutes, put your answer in the chat box. All right, keep putting your answers in the chat box. Well, I would ask you that question. Why would order matter when you're just putting joules in a box? Like, you just think about it, just take less things. If you had one ruby and one emerald, would it matter if it's a ruby and an emerald or an emerald and a ruby? Like, this is the thing, and this is what I try to teach people. Like, you just got to use regular logic. Like, this has nothing to do with the GMAT. This just has to do with good old, regular, everyday logic. If a basket with a ruby and an emerald is the same as an emerald and a ruby, then you have to be able to tell yourself, okay, order definitely doesn't matter here. Because why would it? It's still the same 2 joules in the box. All right, so let's go through this here. So some of you guys had the correct answer, some of you didn't. So the first thing to understand is there's 5 different rubies. 3 of the choices have to be rubies. Now, sometimes people mess this up where they say, well, you're not saying it's only 3 rubies. But when they say if a pirate picks 5 jewels from the chest, 3 of which are rubies, right? That's the same thing as saying 3 must be rubies. So just keep that in mind, okay? They don't have to say exactly or only 3. That just means there will be 3. There won't be 4, there won't be 5. So now this becomes a ruby, non-ruby situation, meaning you don't care that an emerald's an emerald, a diamond's a diamond. You just care that those aren't rubies, right? So the first thing you do here is you're going to calculate the rubies. Now, because there's 5 and there's 3 that we need, we say that that's equivalent to 5C3, right? And then what's left is 7 of the others, and that's going to be 2 more that we need. 5 choose 3 is 10. 7 choose 2 is 21. So you get 210 as your answer. So for those that didn't say 210, does this make sense? Uh, 10 is because you do 5 times 4 times 3 divided by 3 factorial, and then 21 is 7 times 6 divided by 2 factorial. We actually call that the box and fill method of doing combinations. You can also use the combination formula. Both are valid, both work, but that's how those go. Why 7 choose 2? Because, well, I'm going to ask you, how many non-rubies are left over? After we choose the rubies, how many non-rubies do we have? You just type that into the chat box. Well, no, we don't have 2. We need to choose 2, but how many do we have? No, we don't have 3 non-rubies. Go back to the stem. Count how many non-rubies we have. Exactly. We have 7. 4 emeralds, 3 diamonds. So that's 7, and we need 2 of them. because we've already done the rubies. We don't care about the remaining rubies because we're only selecting 3 of them. So once we've gotten those 3, the rubies are out of contention. They're not even in the pot anymore. You focus on the types of things that you're selecting. So notice that when we selected the rubies, we didn't care about the emeralds and the diamonds. Those weren't a part of the selection. So we focused on rubies and then non-rubies. Does that make sense? You add sometimes if it said that you need to get 3 rubies or 2 non-rubies, for example, you would then add. And in fact, what I want to do next is a scenario-based combination problem where you do add, and we're going to do one with an at least 2 situation, and then one with an at least 1 situation. And we have to drop today at 11, so we'll get as far as we can get. In the webinar here. So, all right, I'll give you guys a few minutes, and then we'll chat. All right, so interestingly, a lot of you guys got this correct. So this is where the or comes in. So this is a scenario-based question. And all right, yes, okay, a lot of people will try to do this thing, what you just did, which is a 9 choose 2. Remember, these are scenarios. You can't just engulf it all in one scenario and say, well, it's a catch-all and it gets either, 4 Iranian players, or excuse me, 2 Iranian players, 3 Iranians, or 4. It's scenarios. And so the scenarios are this. You just have to be very systematic. So it says at least 2 Iranian players. So Iranian, Turkish player. That's one scenario. So that's just going to be 6 choose 2, and then 5 choose 2, right? So 6 choose 2 is, of course, 6 times 5 over 2 factorial, which is 2. That's a 3, so that's 15. 5 choose 2 becomes 10. 10 times 15 is 150. And then scenario 2 is going to be, okay, well, how about 3 Iranian players, right? And then 1 Turkish player. So the 3 Iranian players is going to be 6 choose 3. So that's 6 times 5 times 4 over 3 times 2. So that cancels. So that's 20. And then 5 choose 1, which is 5. 5 times 20 is, of course, 100. And then lastly, there's a team that's just Iranian players. So that's going to be I. That's 6 choose 4. That ends up being 6 times 5 times 4 times 3 over 4 times 3 times 2. The 4 and the 3 cancel. 2 goes into 6 3 times, and then that's 15. So 265 is the answer. So really, anytime you see the words at least, or at least anything, it's scenarios. But the thing is, you can be pretty strategic when you see the words at least 1 versus, at least 2. I don't really think you're good. Well, you could see an at least 3, but they're not going to, I guess here's my point. They're not going to make you do 75 scenarios, if that makes sense. So just keep that in mind. You're going to be in a place where it's going to be limited to just a certain number of scenarios. So what I'm getting at here is this one here. So I want you guys to try this, and you can do this one any way you want. I'm going to show you a method that I use for at least 1 problems, but this is a good, oops, hold on. Screenshot's not going to work. All right, try this here. Yes, there is a shortcut here. So when you see the word at least one, you have to understand that there's a very cool equation that comes from these types of problems. It's another probability, in fact. We just don't think about it as much with combinations until you learn it. So the total number of ways to select a group is always going to be equal to the number with at least, sorry, this pen tool sucks, at least one Iranian plus number with 0 Iranians, okay? Now, the reason why that's true is because at least one includes all the different cases where there can be 1, 2, 3, 4 on the team, right? What case is not included? The one where there's 0, right? So because of that, if we can then just figure out the total number of ways, which as someone stated already is 11C4, and we can figure out the 0 Iranian situation, which would be 5 Turkish players C4, then you just subtract. It ends up being, I believe, 330, yes, minus 5, which is 325, and that's your answer. So anytime you see the word at least one, that's how you attack it. We do the same thing in probability, where we'll do 1 minus the probability of the other thing happening, essentially. All right, we can stop here. Any last minute questions before we hop off today? It works for at least 2, but it's not clean. So I say don't ever do it. It's just gonna make things difficult. No, I'm not calculating in my head. I just know it's 330, but you can always do it out yourself. It's not difficult. But yeah, I mean, we have a really cool combinations chapter. So if you guys haven't checked it, because you're not accounting for the scenarios, that's why it doesn't work. You have to account for each individual scenario. What you're showing me doesn't do that. All right, any other questions? All right, everybody is good. We can end for this week. Good work, everybody. Well, maybe we'll do, I don't know what we're working on next week, actually. But thanks for coming. Hope you enjoyed a few things. Check out this chapter if you're in TTP. If you're using TTP, don't skip to it. But it's packed with a lot of really cool stuff. So thanks for participating, everybody. And we'll talk soon. Reach out if you need us.